Hi guys, alright, we are in Unit 1, Day 9 notes, which is solving inequalities, and they're going to be polynomial, rational, and absolute value ones, okay? So we first have to go over what is the inequality, right? So it's the solution. Let's talk about the different types of solutions, comparing it to equation. So the solution to an inequality is a range of values that satisfy the inequality so then let's write our solutions in interval notation. So remember, interval notation means the bracket parentheses, it's not the inequality notation, okay? Alright, so let's jump into examples. So example 1, I'm going to give you an equation, or inequality I should say. So 0 is less than or equal to 2 minus 3 parentheses x plus 1, close it, is less than 20, okay? So this actually has a special name for this. This is called a compound inequality, and specifically there's two types of compound inequalities. There is the and ors. This is an and statement, okay? I know this is an and statement because it has two inequality symbols, okay? I always think of it that it's like sandwich in the middle kind of thing. So this is an and. Our goal again is just to get x by itself. So I'm going to subtract the 2 on all three sides. Please remember to do it on all three sides. Divide everything. Oh no, let's distribute. Negative 3x minus 3, 18. Let's add 3 to all three sides. So 1 and 21. And then of course we're going to divide everything by negative 3 to get negative 1/3. Please do not forget to do this step, guys. When you divide or multiply by a negative, you have to remember to flip the signs. Please, please, please. Okay, I'm going to rearrange this, right? Because usually how we write it is the minimum value goes first. That's the proper notation. Make sure you do that. So negative 7 less than x less than or equal to negative 1/3. Okay, so here's my answer in inequality notation. The instructions said to write it in interval notation. So the negative 7 has a less than, so that means it has the parentheses, and the negative 1/3 had a less than or equal to, so a bracket. That's the end of my final thought. So make sure you put a box around it. Again, if I just asked you to graph this on a number line, let's just do a review. Smaller number always on the left side. Negative 7 has an open circle because it was a parentheses. Negative 1/3 closed because it's a bracket. And I want everything in between them. Okay. If you wanted to check your answer on a graph, you'd graph both lines out. So here are just my axes, and then I want you to graph out at what our two lines is at 0 and at 20. Then I had this linear line. I'll just draw it in like this. and I wanted to know everything in between them. So if I dropped this down, this intersection, this would have been at -7, and then this intersection is at -1/3. And of course, you would tell me what did you plug into your calculator for verifying. So y1 is 0, y2 was the middle portion, and y sub 3 was the top bound. Alrighty, so let's kind of break the notes apart by all the types of inequalities. So the first one we're going to talk about is the polynomial inequalities. And let's break it apart into our steps. So the first thing you got to do is to find your zeros, which I could also call them roots, solutions, x-intercepts. So we want to find them of the inequality. Now, you also have to understand, why do we want these guys? Okay, these guys are called our critical values. So that's what we want to put on our number line. So find the zeros of the inequality and put on a number line. So those are going to be our critical values on our number line. And then step 2, after you find them, you need to make sure that you test the intervals that are between your critical values to know where to use shade. Alright, now that we have our steps, let's just jump into example 2. So x minus 3, x plus 2 squared less than 0. Alright, our critical values, right? Our zeros are solutions here. So when x is equal to 3 and when x is equal to -2. So number line, we already solved for it. So we have smaller number, -2, greater number here. Because it was strictly a less than, we're going to go open circles. And now we need a test. You need to, part of your answer, if you do not do this, you will not receive full credit. And that would be very silly. So you need to show me, what are you testing? So if I'm going to check out this area in the yellow now, I'm going to pick -3. If I wanted to test the middle portion, easiest number is 0 because 0 falls in between. And then if I want to test the right portion, I'm going to pick a 4 right away, okay? Now, pick these values and plug them in to the inequality. If you get a true statement, then we just literally will shade in the area. If it's false, then we do not shade there, okay? Alright, so when I plugged it in, -3, I came out to a true statement. When I plugged in a 0, I came out with a true statement. When I plugged in a 4, I came out with a false statement. The number was not less than 0. Okay, so it passed the 2 sections, and now I need my final answer, like the instructions said, to put in interval notation. So I would be shading everything to the -infinity, to a -2, parentheses because it was an open circle, so there was a break. We union it, and it picks back up at -2, right, with the parentheses, not including it. Keep shading to 3, open circle, and we stop. That's my final answer then. Alrighty, so let's go into example 3 then. Let's solve parentheses x minus 3, close it, square, greater than, equal to 16. Alright, just like our previous notes, how do we get rid of squared? We're going to take the square root on both sides. So x minus 3, I want to just pretend, like you can literally imagine, right, that this is strictly just like an equal sign. That's how we solve inequalities. Plus or minus 4. You can absolutely keep the symbol though. But because it was equal to, maybe it's easier for you. At this point, just like the previous notes, this is where I usually split and write my equation twice. One the positive, one the negative, and we solve. So we're going to add 3 to get x is pretty much equal to 7, right? Or add 3 to a -1. Okay, those are my critical values. So these are the guys that I graph. Here's my number line. I drop down the numbers. Small one, please make sure you write that one on the left side. Great. It was greater than or equal to. So closed, closed. Then I need to make sure I tell my teacher what am I testing. So I'm going to let x equal -2 for the left one. Let x equal 0 for the middle. And then, whoops, let's go 8. That's probably the easiest ones to do. Okay, so I plugged these values into the original inequality and figured out, did it give me a true statement? When I plugged it to the left side, it gave me true. When I plugged it into the middle, I got a false when I plugged in 0, and when I plugged in 8, I got a true statement. So then, lastly, make sure you write an interval notation or solution. So shading would have gone to -infinity to -1, bracket because it's a closed circle, union, pick back up at inclusive, so a bracket at 7, keep shading to infinity. And that's our final answer. Alright, let's go one more. So we have example 4. If I gave you -2 x squared minus 5x is greater than -12. So I'm going to move that -12 over by adding it, setting it equal to 0, right? At this point, I'm going to try and factor this trinomial. Yeah, it's a little bit gross, but that's okay. So -2x and x, 12, so a +3 and a +4. Good. Okay. Zero product property, right? We're solving for these zeros. The first one, +3/2. Second one, -4. All right, then we go into the number line, drop down our numbers, -4 and 3/2. The original inequality was a strictly greater than, so no equals. Right away I go in and I draw in my open circles. You have 3 places to test and to figure out where would you shade. Alright, This is where you take over. You need to make sure that you know where to shade, so make sure right now you complete these notes by telling me what does x equal, and then figure out each section if it passes. Then make sure your last step is to write it in interval notation. Get this answer, and you'll double check with my work later on. All right, keep up the great work.